Hi, my name is Greg Wagner. I'm the assembly instructor for Pima Community College. I'm going to show you in this video how to add assembly into Visual Studio, as well as how to add the Irvine libraries from the textbook for this course.
So to start off, what you need to do is, what I suggest you do is go to the class page. This is for the one for summer 2024, and then go down to assembly languages where the main assignments where you start programming are. I have included this folder, Irvine. There's a file which includes all the stuff you'll need for the assignments and some libraries that you'll be loading. So the first thing you need to do is download these libraries. And to kind of give you some context of what these libraries do, is a library is in essence a compiled program that does not have a main or a driver as part of it. It's essentially a downloaded program. This library, when you compile it into code, will be actually when you build it and then you link it into the code, or link and then load it together, which we've covered in this class. What you'll be doing is linking in. That's what we'll be showing you. So I'm going to download the code you need, and I'll show you how to link in and kind of make an initial assembly program. So I've already downloaded it, and I put it in the downloads, which I already have opened. And so I actually downloaded it twice, just going to see what it was. The one you'd want, the one I linked to the code, the one I suggest you use is about 1.2 megabytes. The other one is a newer one, which is a little bit bigger. But this smaller one has everything we know, plus some stuff that I'll point out later that will be really helpful for doing your projects. So I'm going to extract this, and sorry for the little bit of delay. As you notice, I'm actually running this in a virtual machine. I generally run Linux. And then I'm going to hit extract all, and then this way I can put it in there. So just to kind of copy what the book's using, I'm going to put the Irvine stuff in the top directory in the C drive. This will match up what the textbook and some of the other videos I've posted show. So I skipped ahead to unpacking, and you can see here in the file. So the next step is we're going to do is we are going to walk through in Visual Studio. So I just opened a Visual Studio 2022 version. When you open it up, it gives you an option how do you want to start it. So in this case, I'm going to create a project. And then I'm going to make a C++, so I'll make sure that C++ is selected up here, and empty C++ project. And then I'll name this project CIS 250 main. And for this project, you can make new projects for every one of the labs. I mean, for this class, you can make new projects for every lab, or you can just use this one, send it in, and then just change the code up for the next ones if you don't want to go through the setup again. I'm okay with that. Maybe you want to make different copies of the stuff. I apologize for my dog barking. So I'm going to create this. And so what it's building right here, is going to make the make file, which tells the compiler and the linker and the loader how to build the project. And so this will add as a .proj and a .snl. .proj is your actual project, and above a project in a Visual Studio is a solution which can handle multiple projects. For most of the stuff you'll be doing in this class, and most classes you'll do in college, you only really need a project. The solution to multiple stuff is really kind of more for advanced stuff, like when you have servers and clients. Those would be a server and a client would be separate projects. Usually they line up with the separate programs. So a solution will have multiple programs it can build, or if you have multiple libraries in there or something like that. Like I mentioned before, a library is essentially a program that doesn't have a driver to tell the programmer to start. So it goes to the loader but doesn't have a linker portion of it. So now we're in the kind of the basic Visual Studio thing. So what I'm going to do is kind of give you the steps to actually making the project into an assembly project. So C++ and assembly are very similar. They're very low-level language. Assembly is lower than C++, but C++ is pretty close. And the partner language with C++, C, is essentially just above assembly. And so what I want you to do is right-click on whatever the name of your project is, and then go down to Build Dependencies, and then go to Build Customization. So what a build is in these projects is it links together multiple files. And so what we want to do is add a MASM, which stands for Microprocessor Assembly, or actually the original name was Microsoft Assembly, MASM, and hit OK. So what this will do is now also give us the option to add assembly programs to this. So basically, so it looks for them. And so the next thing I'm going to do is I'm going to right-click on this project again and click on Properties. And again, you can see here you can pick it as Alt-Enter, or if you go to Projects and then go to Properties here, all three of those take you to the same place. I just personally like doing the right-clicking here, make sure I'm aligned with the right project. And then what we want to do is tell the builder where to look for libraries we want to build in and stuff like that. And so in this particular project, we want to go down to, we have this area here, and then we want to go down to the linker. What the linker is the program that links together all the built files. It basically groups them together into one program. And so and so there's lots of different options you have here. And then under the additional, in general, under additional library directories, there's this value here. So you want to put the Irvine library into the additional library directories. So you can type it in, or if you go to edit, it'll give you a pop-up, and it'll actually help you find additional folders for this. And so you do a new line and then click on the three dots. It'll bring up a file that you can select. And so I put mine at the top level of this program, or of this folder in the C directory under Irvine. And then if you hit select folder, it should populate it, and then hit OK. And so if you have any other .libs, like you download some, there's files with .libs for your program, or have something where you compile them, you can add additional .libraries here. When you start building more complex programs, you'll actually not want to build everything. You'll want to get pre-described libraries. And also, a lot of the times, especially if it's very, has a good pedigree, it's been long used, a lot of the C, long-term C files that have been used will be a little bit better quality. So you kind of want to, if there are C files you need for a program that are older, especially for stuff that's security sensitive, like parsing and whatnot, you maybe want to bring those in. So you have this here, and you can just type this in too. I just kind of wanted to show you how to, if you didn't put exactly in there. And then I think all the other settings on this are here. And then if you go back to general, we need to add in some additional libraries. And so, let's see if I can remember where. So we need to add some additional dependencies. So go to the next one, go to the input. And then what we want to do is add some of the Irvine stuff. So in this case, we're going to go in and edit again. And what we want to bring in is under the Irvine stuff. So I open up the Irvine file. We're just going to do a 32-bit processor. So we want to bring in kernel 32lib and Irvine 32lib. So I'm going to just type those in here. I just want to make sure I got the spelling right. And you can just comma separate them. And these just bring in additional library, precompiled functions or in assembly they call procedures that you can use in your programs, which will to do any of the assignments you don't need to actually have these. So if you're running on if you don't want to run on Windows, like if you're running on a Mac, you can use NASM. What I strongly recommend you do though, is you're running Linux or OS 10, get a virtual machine like I have here. I'm on a Ubuntu Linux operating system computer, and then I downloaded VirtualBox, which is a virtual machine that I'm emulating this Windows 10 on. And so I'm going to OK on this. And so what this will do is bring in some of the C files, but we also need to actually have some other additional stuff brought in here. And I shouldn't close this window, go back into properties, and then on the bottom here, let me build this some kind of if there's nothing in this, the build solution would be pretty good, but I actually need it to bring in there's a special thing in the properties that it's not popping up, so I'm kind of just waiting for that to show up. Maybe I didn't add it. So there should be, when you add in the build dependencies of assembly, it should have it did not have the configuration files for MASM, and usually it appears here on the bottom. So I might need to go offline here for a second and try to find it. So sorry for the quick jump. I remembered how to get that MASM stuff. So you actually have to have ASM file in here. What I did was I added main.asm, and you can do that by clicking on right-click on source files, and then do add, and the new item, and then add in a file with the .asm ending. And when it does that, it will load the properties for this. So now if I go into properties, you can see here there's the microassembly thing. But it's very important you have the steps, otherwise your code won't compile. But what you want to add is the include path of where your include files are going to be. And this is going to be the same place as before, so it's going to be c.irvine, c/irvine, or wherever your files are. And again, all this needs to do is point to wherever you put the files. I put mine in at the top level. Some people don't have that ability on their computers, especially if they're like a work computer or something like that, or they don't have the full admin privileges. So wherever you put it, just kind of remember where that is. So now that I have this in here, I can actually build the files. And so what I'm actually going to do is kind of cheat a little bit and bring in a preloaded file and show you how it runs. And you can do this for your project, or also when I show you at the end, there's also some preloaded files that you can use for your project. And so again, I'm going to go back to Irvine, and the textbook for Irvine has a bunch of different files in it. And if you look here, well, the files we want to load for all our projects are going to be irvine32.lib, kernel32.lib, and then Irvine's 32.inc. And Irvine32.inc stands for include. It basically has prototypes, procedure prototypes, are basically like kind of like little skeletons of prototypes that are able to call an Irvine32.lib, which are going to be precompiled code. And so this is just text, and this is binary or executable code. or machine code for Irving 32. And so in this case, what I'm going to do is, in Visual Studio, you can actually just quickly add stuff in. And so I'm going to basically take in add sub.asm and then drag it into my project, and this will add it to the project. And so when you add files into projects, what's happening is you're telling the builder or the program, when it builds a file, load this file up and put it, and you can just drag it in there, and then it will find out where it is based on this directory. And so one of the biggest mistakes I've had when I've been teaching this class, when people have trouble getting their files, is basically the file they're working on is not the one over here. So make sure it's the one that's working on here. So I'm going to add in add sub.asm. I'm actually going to get rid of this one, just so it's not confused and just delete it. And we have this file here. Now what you want to do is, I think we have everything set up. We want to build the project. So to build it, what that does is it runs assembly on the assembly code. It runs the assembler on the assembly code and then links it together. And so you'll see this at the bottom under outputs, and I'll put the mouse over here in a second while it's building. This will generally takes a few seconds. And so it's loading the project. And so what this is doing is basically finding the files that it needs to. And so when it's assembling, it looks for Irving32.inc, which we added, as well as so it's assembling this file, so it's converted it into machine code. And then the Irving32.lib is already compiled, so it doesn't need to do that. Now once it's finished assembling, it needs to link it together. And that's basically a linker is a program that just basically grabs all the files you have in there, any of the source code that you have, which are converted into object files. Object files and libraries are essentially the same thing. It's basically machine code. It's basically machine code. And then the next step is you also have a loader, which tells the which has basically a key in the front of the program that tells the operating system which line of code to start, what address where to start running the code. And so that's going on right now. So unfortunately this failed, and so maybe it's a learning thing. It wasn't able to find Irving32.inc, and so what I probably did was I just didn't either save the properties correctly or something. So I'm gonna go in here. You can actually edit it. Let me just make sure I have the right file. Oh, and so actually none of this code is going to run. I made a big mistake. So it's actually an C:\Irving. So I can go in and fix that. I'm going to just cut and paste this. And then also I need to go in, since this file is not correct, I need to go in and change the linker files to which files we're going to grab. And so and let's set it. And for whatever reason, I didn't set this anyway. So this wasn't going to build. So in this case, I'll just cut and paste this value here. And so, and then let's make sure I input files. These are not. So let me, probably what I did is I just canceled it. Let me go in and also, so this wasn't going to run. So you need to have, again, Irving32 and then input libs here. I'm just going to go in the editor. It's going to be system 32.lib, or I'm sorry, kernel 32.lib and Irvine 32.lib. Apply this, and then let's make sure everything's working. And I'm going to build this again. And so up here you see a bunch of different kind of solutions. You have build, rebuild, and clean. What clean does is gets rid of all the executable files that you built. So it gets rid of all the .os and stuff like that. And this just happens if you make a lot of changes over a while. You want to do that just to make sure everything's linking together. And then what rebuild does is that it rebuilds all the object files. What that means is when you do a build, just to save time, it only assembles the files that you changed. What rebuild does is all of them. So it essentially cleans the project and then does a build. And then build just compiles the files that you've modified. And so for most of our projects you've probably seen so far, you've only had a few files. But as you start adding more and more files to make it faster, the build process, you just use a build. You use a build to do it, and it'll just update the files that you've already built. And then you can see here, we're building the source code again. And this one, so it cannot open kernel32.lib and everything32. So it probably means I couldn't find them. So let me make sure that we have everything in place. So I'm going to cut and paste the names just to make sure I have them right. We are getting a little bit better, and so those are there. And I think I actually need a comma I have them comma separated. I think I actually need a semicolon separate them, so that might be one of the issues. So make sure to apply it. And then also I'm going to go into general and make sure that we have the Irving things, which we do. And so I'm going to hit OK and then try building one more time. And since I'm running a virtual machine that's going to be running really slow, generally it's going to build faster on your own computers. But for whatever reason, assembler is probably not as efficient as a program as most compilers you have, so it might be a little bit slower than this. And another thing is, for you guys, if you have really strict virus issues on this, so this one built, that semicolon issue there, but also most viruses are built using assembly, especially the older ones. And so if you're building assembly and your operating system is maybe not talking to Visual Studio, seeing that you're building assembly, and it sees an assembly program being built on your computer, it might think that there's a virus that's replicated on your computer. So either your Windows Defender, basically your antivirus software, might put it in there. So what you might have to do is put an exception in for this folder where you have your files when you're putting the files in. I'll show you where that is kind of at the end. So this program built, and I'm going to run it. But one thing I want to do is, one of the things I think that's really good about using IDEs, especially ones that are proprietary like Visual Studios, they have really good debuggers. So what I did here is I put a breakpoint. And what this will do is we'll stop the code as you're running it. And then you can see what's happening in the program and see what the values are. So in this case, I'm going to run it with the debugger. And since the project's out of date, so yes, I don't know why it needs to rebuild, but while it's going in there. But so what a debugger allows you to do is see what the memory is, see what's in the registers, and stuff like that. We'll get into a lot more into the registers going forward in later classes. But we kind of did. If you look at the notes from before, we did cover the EAX register, which is a 32-bit register, and the EBX, ECX, and EDX registers, which are all 32-bit. So it's running now. And so when you know it's running, you'll see this console window pop up. This old-looking DOS window pops up, and it's converting. Now you can see in the background it changed states, so it's going into the debug mode. And so some of the things I'm going to show you here in a second only run in debug mode, and It's taking a long time to get going. Okay, you know it's stopped when you see the little yellow arrow where you put the breakpoint. So now that we're in the stop area, I'm going to bring up a few things. So this journal setup you see here is generally going to be considered for like running like basically high-end C++ programs. So you don't need the diagnostic tools at this moment. But down here you have the variables, and so this will be the variable watcher. You can see what different variables you have. And then I'm going to bring up two more things. You'll see this when I do other examples in this class. So now that you're in the debug mode, if you go into debug, you can add a few extra windows. And this is I think will be really important for this class. So one you want to go down and click on registers. And this will only be available while you're in debug mode. So you need to stop it and then to add this. So this will show what all the values of the registers are at this moment. And then also go to bring up memory and just do memory 1. And this will be more later, but you kind of want to set this up. With the memory 1 will show exactly what's in your memory when the program's running. And so in this case, if you look at the registers, you can see there's certain addresses in here. So other registers that are showing, we have EAX, EBX, ECX, and EDX, which are the 4 main registers on a Intel processor. And then we have the EI, and the E stands for extended. So right now I'm running just a 32-bit emulation of a processor. We're actually, probably all your computers have 64 bits. So there's a few more different registers for this. We have EIX, EDX, which stands for extended. The S stands for source index. Basically, the EIX and then D means destination. These are two 32-bit registers, essentially for passing addresses between for basically like media, so strings and videos and stuff like that. You have the EIP, which is going to be the instruction pointer. This is where in memory we are in the instructions, and you'll see this change at every step. The ESP, which is the stack pointer. EBP, which is the buffer pointer. We'll get into this later in the class. And then the EFL, which is the flags, which next homework assignment 3 goes over these. So now that it's running, so what I want to do is I'm gonna step through this. So if I go to debug and then go step over, or just hit F10, which I'll be doing from after the step forward, you can see the register value change in EX. And when it changes, when variables, you'll see if you see any variables down here where the registers change, they'll be the color red for the next step. And so in this case, I'm passing in the value 10001H, H means it's in hexadecimal, into the EAX register. And then I'm going to add the value in the EAX register by the value 4, and so this value up here is going to become 5. So I hit F10. You see the 5 here, and then also notice how the instruction pointer changes. The instruction pointer changes, and then the flag pointers. So whenever you add or subtract something, your flags are going to be modified. And we'll go over what flags are for, but generally they're for basically helping with conditional statements. You can tell if you need to go if something's less than or greater than, based on what's in the EFL. And then the next one will do a subtraction. The value changes again. And then the reason why I have you guys do the Irvine stuff is there is a function in there called dump registers. And what this will do is, notice here, we have nothing on the console. I'm going to hit F10. And now we have the value. So this dumps all the registers. The values up here should be the same as up here. I mean, if you're using a debugger, you don't really need the dump registers. But I mostly just did it so you can see this stuff. And then you continue to the end. And then if you want to run it without the debuggers, you can get rid of these by just clicking on them or leave them in or whatever. And then one more thing I want to show is notice here we have all the code's going to be broken up here. And if we had any variables, which I'll show in the next example, they'll be above this. We have the include, and then we have the setup. So what I strongly suggest you do is you take this one or the example I'm going to show here in a second and then put those together. So I'm going to kill this and then open up a new project. So I'm going to close the solution, but I'm going to leave Visual Studio up. Visual Studio uses a lot of memory. And so while this is going, um, if you go into the Irvine code that we have, this is one of the reasons why I insisted that you use the 2017. The other ones don't have this, but there's also an example of project example. And this will actually have an example project. And if you click on this value, the solution, it will load up, it will open up Visual Studio for you. So I'm going to actually close Visual Studio. Actually, I don't really need to. If you want to, you can also just drag this in here. If I drag this in, it's going to load the solution for this, which will include the project files. And so it loaded it. And then so since it's from older version, just hit OK. And basically what it does is it changed the solution and the project file to line up with whatever version. In this case, I'm using Visual Studio 2022. And again, if you use the later versions of Visual Studio, it doesn't really matter. And then notice here we have a main file. I'm going to double click on this, open up main, and you have another project. And so notice here we have a little bit more structure. We have a data, and so data is where you have all the old, this is where you actually have variables. So this is values that are stored in memory, and then you also are loading up here. And what this is an example of is showing, doing a hello world. So in this case, the first part of project 3 is actually, for lab 1, is to modify this so it changes the text and then run it off. So, but notice what I did here. Now, when I dragged in the project, everything is set up so this will actually run. So this is a new file, and then if you look at the properties, this is set up, and so this is the wrong directory, so I'll need to actually fix this. And then, so we have these. This looks good. Irving 32, actually user 32. You might want to add that as well. I don't think you actually need it that much, but you might. And in this case, I need to modify this one as well. So now when I build this should run. Actually, I'll just run it. And then while this is running, there's one final thing I want to show you. Wherever your code is, so your code is going to be, by default, when you make a new file, it's going to be in your particular project. And so it may not be obvious of where that's going to be. So what I want you to submit is just your assembly file. You don't need to send the whole project in. It's going to be tens of megabytes to do the whole assembly. So we actually ran this. And so you can press any key to close the window. And so let me show you. So to find out if you don't know where your files are, the trick I do is if you just right click on a file, or click on file, and then do save main as, it'll show you where it'll pop up the file explorer that pops up will show you exactly where the file is. So you don't need to do this, but so in this case, it's going to be under Irvine examples, project sample. Yours might be in another place. Another place you might want to look is under documents. If you go under Visual Studio 2022, wherever you put it up, and then, or maybe repos. If you go to Visual Studio repos, it should be in there. In this case, I have CIS 255 main, and then the file you want to do is the one you're working on. And then go under, sorry I went so fast. Click under whatever the project name is, and you should see, or if you want to run you should see the executable in there. And then is this not popping up? So the main projects. Oh, well, because I didn't make any files. I deleted them, but you should be able to find it in. So whatever it is, just make sure you send in just this file. That's all I need. I'll build everything else when I grade your assignments. Actually, what I'll probably do is just use this setup and then leave the project open and delete your other colleagues, your other students, your other co-students in theirs, and then just add yours. Is generally the way I'll grade these. So I hope that this helps you get started with the project. And it might be a little bit overwhelming to start, but you always just rewind and go through this. And so if you have any questions for me, please ask or email me, and I'll get back to you as soon as I can.